Welcome to STEM School. Last time we studied simple proofs, odd and even numbers. Now we're going to be looking at proof by deduction. So the best thing is to define what proof by deduction is. So that is a proof by deduction is when you use known facts to build up your argument. So you use something that you already know that actually is true to support your argument. And therefore, argument and show a statement must be true. So that's the definition that you could use to define proof by deduction. So the example we're going to apply is, let's look at a definition. I use capital D because it's a definition. That's a known fact that we're going to state now, of a rational number is a number that can be written as a quotient. Quotient means divide. In this case, as a quotient of two integers of two integers. So basically, as a fraction. So it can be written as a fraction. That's another way of expressing that. And of course, where the denominator cannot be zero, is non-zero. Because if it's zero, then it's undefined. So a quotient of two integers will be, so a quotient means divide. So quotient means divide. So that's a divide line. And you have a numerator and denominator, which in this case, you cannot, or you're not allowed to have a numerator with zero. So that's undefined. So that's what that's saying. So you can have a fraction with a non-zero denominator. So that's rational number. Now we know what a rational number is. Now we can do some examples to prove by deduction. So this is it. We're going to use this definition of rational. So we're going to use this definition of rational number to prove, because we now know what the known fact is. So the known fact is a rational number in this case. So we're going to use that to prove that the following statement is true. So we're going to use that to prove that the following statement is true. And what is the statement? So this is the statement here. So we say that the product of two rational numbers is always a rational number. There you go, that's the statement. So what we're now going to do now is to basically justify that statement. And in order to do that, so let's try it here. So we're going to have to take two rational numbers and call them A and B. So we take two rational numbers, we call it A, rational number A and rational number B. By definition, a rational number is basically what? Is a quotient of two integers. So I could call my A to be P over Q and my B to be R over S. So I've got, and the statement here is that two rational numbers. So I've got my first rational number here, A, and my second rational number, B. And so what we're going to do now is find the product of those. Product means times. So product means times, and quotient means divides. So now we're going to basically multiply those two together. So therefore I'm going to get, what am I going to get? I'm going to get A times B should be equal to P over Q times R over S, which implies that P times R over Q times S. Now bear in mind that P, Q, R, S are all integers. So where P, Q, R, and S are integers. So that will give us PR over QS. So now what we can do is state that, well, PR will also be an integer called K, and QS will also be an integer called L. And therefore, from my calculation here, I should get A times B, which is AB, should be equal to K over L. So that's another fraction that we're talking about right there. So that's another rational number that we're talking about there. Right. As you can see, it's fairly intuitive, so it's pretty clear. And let's hope you understand that. Thank you.